and welcome back to my channel. So we are getting into the network design, and this is the fun stuff right here. So on the board, we have a network design. This is where we take all of our knowledge of subnetting and IP addressing, and we start doing network design. And in this scenario, we got this Class C network. As you can see, it's a Class C. 192.168.1.0/24. And we want to chop it up. We want to create multiple subnets for our organization. So we want to chop it up into different subnets. Subnets for our organization. And here's the formula that we want to study for the Ccna²⁶301 exam. This is a great example that you can study from. So we will calculate the number of subnets that we create when we add bits to the subnet mask. We're going to say, excuse me, it's 2 to the power of S. 2 to the power of S. Where S is the number of borrowed bits. And you may ask, what's a borrowed bit? Glad you asked. Borrowed bits are what we add beyond the natural mask. So if we don't know what the natural subnet is or the default subnet mask, we may not know how many borrowed bits we have. That's why it's very critical, guys and ladies, to know the default mask for the different classes of addresses. So in this case, we want to say we've got a subnet mask of 255.255.255.224, and we apply that subnet mask to a C network of 192.168.1.0/24. And the question is, how many subnets did we just create? Well, we need to figure out how many borrowed bits we have in order to do that. Let's say we got 8 plus 8 plus 8 in the first octet. And we got 128 plus 64 plus 32, and that's 224. Okay, we got 3 bits on our fourth octet. 3 ones, and 5 zeros. So we have a grand total of 27 bits on our subnet mask. The question is, how many subnets did we borrow? It depends on the class of network that we actually have. If there is a 172 in the first octet, Then I will borrow 11 bits and the math would be totally different. But because it's a 192, in the first octet, I know it's a Class C network. It's a Class C network. And I know my default subnet mask is /24. So we only added 3 bits. So let's plug and chug. Let's put 3 in the place of the S. And it will be 2 raised to the power of 3, which is 8. Two raised to the power of 3 equals 8. We just created 3 subnet masks. We just created 3 subnets. How many subnets are created? Three. Borrowed bits 3, which means we created 3 subnets. So here are the available subnets that we created. Notice that we've got a usable host address range for each of those. So if we go into the book, the CCNA book, we see that 255.5/2024 slash, and it's going to be so we got a useful host address range for each of those. There is a trade-off though. We take a network and chop it up into subnets. Each subnet could accommodate a fewer number of hosts than the original subnet would have accommodated. So as part of our calculations, we need to know if we have enough addresses to hand out as host. And then we go to host. Calculating available host. The number of assignable and the number of usable addresses in a subnet. Another formula for us to use is 2 raised to the power of h, as you can see right there on the binder, where h is the number of host bits. Those zeros at the end of your subnet mask, that's the number of host bits we have minus 2. And why do we have to subtract 2? Because we cannot assign the address, we cannot assign the network address where all host bits are set to 0. And we cannot assign the directed broadcast address where all the host bits are set to 1s. For example, subnet mask of 255.255 192.224 is applied to a Class C, as you can see on the notebook, it states this, network of 192.168.1.0/24. So how many hosts can be assigned in each subnet mask? Number of ones in subnet is 27. Host bits is 32 minus 27 equal 5. Number hosts 2 raised to the power of 5 minus 2 equals 30. Because we're not allowed to assign the network address, which is what I just stated, and the directed broadcast 2. So in the next example, we are slicing 27 subnet max. So how many hosts are we going to be able to create in each of those 8? Well, to raise 2 to the power of h, we have 27 network bits. As I just stated, it's 32 bits. The whole address is 32 bits. So what's left is 5. 32 minus 27 equals 5. So it's raised to the power of 5, which is 32. Then subtract 2, and that gives us 30. So we have taken network class C, and chopped it up into 8 subnets. Within each of those 8 subnets, we can assign 30 PCs. That's the goal, right? We can assign 30 PCs, and we are going to do the 30 IP addresses, and that's the goal. So thank you for listening. Thank you for subscribing. Keep on studying for the Ccna²⁶⁵, and I wish you well. Good night.